Alright, this video I'm going to talk about the probability of disjoint and overlapping events. Before I get there, I just want to quick review some common vocab words that kind of tell you what to do on probability problems. And those words are and, or, and given. Those three pieces either allude to a formula or just kind of tell you what you're going to do with your fractions, from there. Whenever you can think of a situation where you got to get this and that means you're going to multiply your numbers. Whenever you get a situation where you can have A or B, that's going to be adding. And then whenever you see given, that's always looking at the probability of like B that slash given A. That means given right there. So when I say given, I'm thinking about this piece. So if you have a formula sheet or anything like that, given and this kind of coincide. So let's get to what I want to talk about. So given a standard deck of 52 playing cards, so I put that there, what is the probability of drawing a 7 or a jack? So I need a 7 or a jack. So I'm going to use highlighters here to kind of show a few things today. So let's look at and focus on 7s. So all my 7s are right here, all in this section right here. So let's figure out what's the probability of getting a 7. Well, right now there's 1, 2, 3, 4 total 7s out of, and all these possibilities are available, 52 total cards, 4 over 52. And then let's look at jacks. So what's the probability that you get a jack? Well, all of my jacks are right here. So you'll notice again the probability that you get a jack, 1, 2, 3, 4 out of 52 total available. Now the key word there was they said drawing a 7 or a jack. And I just talked about if you have an or, that means you're going to add those together. Notice my fractions here. We have common denominators. If you really wanted to, you could do this all in a calculator. But what happens is you get 8 over 52. 4 plus 4 is 8. 52 is on bottom, stay the same. And 8 over 52, that is 0.1538. So the probability of drawing a 7 or a jack is 0.1538. Let me show you one more example. So what's the probability of drawing a club or a diamond? Well, I'm going to use blue for that. So a club or a diamond. The clubs like that. Diamond. Club or a diamond. So all my clubs, I'll put that in blue, are all up here. So how many total clubs are there? If you count them all up, there's 13 out of 52. 13 out of 52 total outcomes are clubs. The or means, hey, we're going to add there, and then diamonds. So all my diamonds are, well, right below it. So here is all my diamonds. So there is 13 total of those out of 52 as well. When you add those together, you're going to get 26 over 52, which that is 0.5. So pretty standard, if you see or, add them together. On the back side here, I'm going to show you a few more examples where things get a little bit more interesting. So what's the probability of drawing a 4 or a heart? 4 or a heart. Let's start with 4. And 4s, I'm going to put that in blue. Well, all my 4s are right here. So the probability of getting a 4, well, there's 4 total 4s. 1, 2, 3, 4 out of 52. The or again means, hey, add these together. And then a heart, I'm going to put that in yellow. So let's look at where all of my hearts are. Well, those are all right there. Now, hopefully, you might have noticed something on this problem compared to the first two. Well, let me finish this out. So the number of hearts there is 13 out of 52. So we aren't just going to add these together. We're missing something here. The thing that's different is notice how we crisscrossed what I highlighted there. What happens is I counted this 4 2 times. I counted it over here, the 4 of hearts over here, and I counted the 4 of hearts over here. So I overlapped over one of my outcomes and I counted it twice. So we're actually giving ourselves a little bit of extra probability. So since I counted this twice, I only want to count it once, let's subtract off how many times I overlapped. Well, I overlapped one time out of 52 total times. Now what that is doing is if I added up all these, I'm counting 1, 2, 3, 4, 5, 6, 7. I don't want to count this again. 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's what I'm trying to do. Now if I do the numbers down here, I'm subtracting off this 1 out of 52 because I counted that twice. So when you add these up and subtract, so 4 plus 13 is 17, minus 1 is 16 over 52. So what we're doing there is, again, I think that's 3.677, or is it 3.077, something like that. I have it on my notes and it's not legible. So again, what's happening here is I counted 1, 2, 3, 4, 5, 6, 7. Don't want to count this again. 8, 9, 10, 11, 12, 13, 14, 15, 16. That's kind of what this math is going on here, and that's how I got 16. So I counted these 4, those 13. Since I overlapped here, I had to subtract that off. So down at the bottom it says, what's the probability of drawing a club or a face card? So I'm going to do these. Let's do these. I'll do the clubs in yellow. So let me look and see where all my clubs are at. So I kind of have to ignore my blue yellow that I already put on there. All of my clubs are all up here. So how many total clubs do I have? Well, that is 13 out of 52, or means I'm going to add there. And then let's look at our face cards. So if I come back up here and I look at my face cards, that is all of these right here. Now it's getting a little bit messy because I've colored on this twice, but what you should have noticed is we overlap there. So first off, let's count out how many face cards I had. So all this orange, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 52 are face cards, but here's the deal. We overlapped. You know, I had my yellow here and my orange here. We overlapped on those 3 cards. We overlapped on the Jack of Clubs, Queen of Clubs, and King of Clubs. That was 3 cards that we counted twice. So what we're going to do is subtract off those 3 cards. By subtracting it off, sorry I can't see that, by subtracting it off, you're making sure you don't count it twice. So now we could actually calculate this out. So 13 plus 12 is 25, minus 3 is 22, still have a 52 on bottom, and that is 0.4231. By the way, up here this is 0.3077. That wasn't a 6, 0.3077. I checked it really quick. So the probability of drawing a club or a face card is 0.4231. So why is there a difference in problems? What it has to do is you can think of a Venn diagram. We could have Venn diagrams that never overlap. In probability, that's called disjoint. Or we do have overlap like we had on these problems. And what happens is those Venn diagrams, those circles, overlap. So there's 2 pieces there covering each other. So we want to subtract one of them away is what's going on. So we have disjoint and we do have overlap there. In general, the formula here is whenever you have overlap, you're going to have the probability of your event A, and this is for the probability of A or B, which is called a compound event. You have the probability of A plus the probability of B, but you want to subtract off that overlap, so where you get A and B. So that's kind of what we had here, probability of A, probability of B, subtracted off the overlap. So that's only if we overlap do we do this. If you'll notice on the front, we never subtracted off because we never had overlap. So I colored over this, but what happened is we never had overlap. We had disjoint. So the official formula there is P, A, or B, and this is for disjoint events, is the probability of A plus the probability of B with no subtraction. And that is the probability of disjoint and overlapping events.